stw5000cem. Today I am here to give this presentation on my project of AI. I'm from Software College of IT and E-commerce. Welcome to my demonstration of Introduction of AI module. In this video, I will present how we developed an AI model to predict high respiratory hospital admissions using air quality data. Air quality data. Every year, millions of people suffer due to poor air quality in Nepal, especially Kathmandu. Air pollution often spikes during winters, leading to hospital overloads from respiratory cases. My goal was simple yet impactful: use machine learning to forecast days with high respiratory planning and public health alerts. This is the air quality data health set dataset. I used real dataset combining daily air quality indicators such as PM 2.5, NO2, SO2, CO03, along with corresponding respiratory admissions. Given size constraint, I took a 10% stratified sample to preserve label distribution. In this label distribution, I created a binary target high respiratory admission using the median admission value. Drop irrelevant columns: region, date, region, region, and all types of data sets, and scale all remaining numerical features using standard scalar. In this standard scalar, I used standard scalar X scale PT data frame scalar to train test split. Various models were considered: logistic regression, SVM, gradient boosting. I settled on random forest, valid for its robust accuracy and interpretability using stratified k-fold with 5 splits and randomized source CV. I optimized parameters like number of trees, tree depth. You can see the max depth of 5, 10, 15. The final configuration included balanced class weighing to mitigate any level imbalance. Imbalance, random source optimization, scoring F1, 10. You can see the code for estimator RF and param distributions param grid. Now I would like to run the project to see its results in action, such as bar charts of class distribution, confusion matrix heat map, ROC curve with AUC. Now I'll run the project. You can see here's the class distribution, roughly balanced between high and low. 0 meaning low and 1 meaning high respiratory admissions. The highest in this is 175 and the lowest is 125. Now next is the confusion matrix, which should be loaded any minute. The confusion matrix shows strong classification performance and few misclassifications, 20 being the highest and 12 being the lowest. This is the receiver operating characteristics curve, ROC curve, which delivers an AUC of approximately 0.86, pointing to high predictive accuracy and excellent 0.54 excellent predictive accuracy and excellent false positive rates. This bar shows top 15 features. Humidity can be seen as the highest at 0.08. The lowest is industrial activity of 0. In the middle of 0.03 and 0.04. Now next is the sample decision tree diagram. The maximum depth is 3. In this you can see the decision tree sample illustrate how pollutant threshold leads to admission prediction. This transparency albitros essential when working in public health domain. Now I am going to show you the code. Here is an overview of the key code steps. Importing libraries, importing of libraries, loading data, sampling, creating target labels, splitting data, scaling, setting of the random forest and random source lifecycle, evaluating performance with metrics and plots. I documented everything thoroughly. Version control via GitHub for reproducibility. Feature importance PD series. I also compare random forest against the logistic regression and k nearest neighbors. While logistic regression had decent accuracy, it struggled with non-linear regressions and delivered how lower F1 scores, particularly on the minority class. Random forest consistently outperform in both predictive power and interpretability. This makes it especially fit for external healthcare advice, future work, and closing. In future, with this project, I would like to extend the model with time series forecast using LSTM, integrate a real-time API service for alert generation of the air quality, and deploy a web dashboard for hospital and public health officials. I also intend to incorporate explainability frameworks like SHAP and refine feature transparency. Thank you for watching. I am happy to answer your questions in the Fiverr or presentation session. Thank you.